Hello, everyone. Let's talk about another Leetcode problem today. And today we're going to discuss problem 11, container with most water. And this is one of the problems in the blind 75 list. So the problem description says that we are given an integer array of integer array, and the name of the array is height, and the length of the array is n. That means there are n vertical lines drawn such that two endpoints of the ith line are I0 and I height. Okay. So say this is the line. This is the line. Okay. This is the line. So the endpoints are like I0. That means you can see this is 0, right? So this is 0, 1, 2, 3, 4, 5, 6. I6. So this point is 6, 0, and the other endpoint is 6, and you can see this is 8, right? Okay, 6 and 8. Okay, so the endpoint, the ith line is going to be like that. We have to find two lines that together with x-axis form a container such that the container contains the most water. We have to return the maximum amount of water that the container can store. Okay, so let's look at the first example. In the first example, you see that the height array that we're given looks like this. That means there are like this has a size of 9. That means this represents 9 lines, and each one actually, by the definition, the first line is 1, right? So it means that at position 0, one endpoint is 0. Sorry, one endpoint is 0, 0, and the other endpoint is going to be 0, 1. Okay, so that is the definition. That means each of these values represent the height of the line. Okay, so this one, you see the first one represents height 1, the second one represents height of 8 at position at index 1, right? And the last one, this one represents height of 7, the line height is of 7 at index 8. Okay, so we have to find the area between two lines that can contain the most water. Say, okay, let's say uh, if this is one of the lines and this is one of the lines, tell me how much water they can contain. Well, you see the height of this line is 1 and the height of this line is, say, 2, right? Okay, so when we are actually have a something like this, say something like this is height of 1 and this is height of 2, right? So how much water it contains between them? So you see there is like the difference of index is like 1, 2, 3, right? So that means if you want to put water in it, always what's going to happen is the water will be at the level of the height with the lower height, right? Because you cannot actually pour water here, right? That will actually drip or that will flow down. So it means that if I want to uh, contain water between two walls, the height of the water is going to be equal to the lower wall, right? So the amount of water is going to be minimum of the two walls, that is 2 and 1, into how many spaces are like in between, how many indices are in between? 3. So that means 1 into 3 equals to 3. Okay, so you got what I am trying to say. Now we have to find those two walls which in between them contains the highest amount of water. Okay, so let's think about the solution, how we can do that. Can we think about the most naive way to solve this? I will give you a minute. Uh, just come up with some solution and then you can come back, or you can take your time. Okay, so if you're back, Now probably you have found a way to solve this problem. Why don't we just try the container between every wall, right? So let's try the container between index 0 and 8. How much water is going to be contained in there? So there are like 8 spaces, right? And the minimum wall height is 1. This has a height of 1, and this one has a height of 7, right? So the minimum of 1 and 7 is going to be 1 into 8. That means if I have a container that is in between these two walls, this is going to be the water, right? This is going to be the water, and this is the volume of this water is 8. Okay. Next, what we do is we can just keep on repeating this for every other thing, right? So, so let's say, so let's find the amount of water between 0 and 1. 0 and 1, you see there is 1 here, and the minimum height is 1. So the volume is going to be 1. Between 0 and 2, the wall height is, minimum wall height is 1, and this although has a height of 6, but the amount of water is going to be these two, right? So between index 0 and 2, the container can have maximum of 2. Between 0 to 3, the amount of water can be, again, is going to be 3, right? Because the wall height is 1 here. Okay, similarly, let's say if I take between two index ones, between index 1 and index, say, 2, how much water is going to be there? So between this index and this, we can have water of this amount, right? So this is, minimum is going to be 6 into 1, that is 6, right? Okay, so the amount of water is 6. So we can take every pair, and what we can do is, so for two indexes I and j, right, the amount of water is j minus I. This is their distance in the along the x-axis, into a minimum of, we're given the height array, right? So minimum of height I and height j, right? So that is the naive way. What is the time complexity of this algorithm? The naive way, we are taking every pair, right? We are taking every pair. So how many pairs are there? So there are like n square pairs, right? For an array of length n. So for n square pairs, we have to calculate this and then find the maximum. This is order of n square. Okay, so for the second example, you see we have like only two walls. This is y-axis, this is x-axis. We have just two walls. One is 1. The second one is also 1. So the amount of water is going to be, obviously we have just one container. So this is going to be 2 minus 1. This is the index is, this is index 0 and this is index 1, right? It will be 1 minus 0 into minimum of 1 and 1, that is 1. Okay, so the amount of water is going to be 1. So that is the order of n square solution. Now, by now we have the intuition that if we have a container of two different wall sizes, then the amount of water is going to depend on the wall that has the lower height. And we know how to calculate this. So why don't we just try to do it in a more efficient way? We can use 2 pointers, right? We can start from the left and then the right, okay? And what we can do is we can just calculate the volume. So this is the most wide container, right? We can start over there here and see what is the volume. So we have 2 pointers at left and right. So what is the amount of water? So amount of water is going to be 8 minus 0. This is the distance along the x-axis, into the minimum height. So you see this one has a height of 2 and this one has a height of 1, right? So the minimum wall height is 1. So the amount of water is going to be 8. Okay, so this is the volume for now. Okay, so now how do I move the container? As you can see, we have the widest container, right? This is the widest container. So if I want to, and we have a water volume of, how much we have? Like we have a water volume of size, say, this is the water, right? Volume of 8. Okay, so we want to find now we want to find a narrower container, right? Can we have another container that contains more water? Yes, obviously. For that, what we need is we can reduce the width. So we can reduce the width, but if we have like two very tall walls, right? So we are going to look for tall walls, and that may maximize, even give me more area for water, right? So what do I do is we just move the pointer that is smaller. That means we are looking for a taller wall. So why don't we just move this? Right is smaller, so we move right to here. Now you see that the amount of water is going to be like this, right? So it's going to be 7 minus 0 into the minimum of, this is 5 and this is 2, right? Minimum of 5 and 2 is 2. So now you see that my volume has increased. If I take these two walls, if I take this wall and this wall, the amount of water that I can take now becomes 14, which is even more, right? Okay, but we will try the other ones, right? So which pointer we want to move next? So we want to move the smaller wall pointer, right? Because potentially we can get even a higher wall, which will increase the volume of the water. So that's for that reason we will move this time. Right has a height of 5, left has a height of 2. So we are going to move the left to the next, and this time you see the volume is going to be 7 minus 1, that is the distance in x-axis, and the wall length, this one is 3 and this is 5, right? So minimum of 3 and 5 is 3, and this is 21. Now you see the volume has increased to 21, right? Next we move, so for the next ones I will just fasten it. So we are going to move the smaller wall, and the new left is going to be here, right? So it's going to be 7 minus 2 into, this time you see this has a height of 1, right? So the minimum height is 1. So this is 7. Already we had like 21. So this is not going to help. Anyways, we have to move, and this time the smaller wall is going to move, and we have this, the new one. Now this one has a height of 7 and this one has a height of 5. So the volume is going to be 7 minus 3 into the minimum of 7 and 5 is 5. So 20. So you see we have 20, but already we had a volume of 21. So this is not going to. Okay, so next we move right. This one has a height of 4. So this time it will be 6 minus 3 into minimum of 4 and 7, that is 4. It's going with 12. So it's still, it's less than 21. So moving right, because this is smaller. Okay, this time you see that both of them has a height of 7. So it's like 5, index 5 minus 3. That is the distance in their x-axis. They have a distance of 2 and into 7. So that's going to be 14. Still, it's less than 21. Next, both of them have the same height, right? So both of them have the same height. So we will just, in that case, what you're going to do, we're going to move one of them, any one of them, to tie break. So for this example, we are going to move left. So the new left height is going to be 2, and left pointer is going to be here. Sorry, left pointer is going to be here. And now the volume is going to be 5 minus 4 into minimum is 2, right? So this is between two walls of height 2 and 7. So this is going to be 2. So finally, none of them could topple 21. So this is the highest volume of water that we can store between two heights. Okay, so next we will try to code this thing, and this is going to be a simple code. And what is the time complexity for this? So you see, either we are moving the left pointer or we are moving the right pointer. And we are doing this until the left pointer is less than the right pointer, right? So overall, if this is like the size of n, together left and right pointer moves, how many places they move? They move n places, right? So together they're going to left and right. They're moving in opposite direction, but together they move in n pointers, right? So this is going to be an order of n algorithm, and we are not using any extra memory. As you see, we are just so this is a method called two-pointer method. You will solve other problems with two-pointer method, and this is one of the strengths of array, because you are given an array. In that case, you can just go to any index and just move forward or backward. So using the strength of the array and using the two-pointer method, we can solve many problems very efficiently. So let's code this. We'll have a left pointer. It will be pointing to the first index, and then we'll have a right pointer that will be pointing to the last index. And then we will have a variable for volume, which will count the maximum water volume. It will hold the maximum water volume, and then we'll move the pointers, and we'll have to make sure that the left pointer never crosses the right pointer. And once we have the left pointer and right pointer, what we can do is we can calculate the new volume. So the new volume is, okay, so we'll take the maximum of the previous volume and the new volume. So the new volume is going to be, let's calculate the new volume, is going to be right minus left, that is the distance along the x-axis, into the minimum height at left index and right index, minimum of these two. So if we have a bigger volume, this is going to be updated. Otherwise, this will remain the same. And then we'll check if left height is less than equals to the right height, then we're going to move the left pointer. Otherwise, we're going to move the right pointer. And finally, after we are done, volume has the highest, VOL has the highest volume stored in it, we'll return it. Okay, so let's run it. There might be some typos. No, accepted. Okay, this is accepted, and this is an order of n algorithm. Thanks for watching. We will come back with another problem.